All right, class, next section, 8.4, day 1, properties of rhombuses, rectangles, and squares. So all of these different quadrilaterals have different properties that indicate which type of quadrilateral they are. So we already talked about parallelograms, but let's go ahead and review that real quick and write this down. You have this quadrilateral family tree in the back of your note packet. So flip over to the back of the notes packet and we'll fill out this quadrilateral family tree, or at least some of it today. So first are parallelograms. And these are off to the right of the quadrilaterals. You'll write parallelogram and then a little circle off to the right of quadrilaterals. Your characteristics for parallelograms, like we already talked about, are 1, both pairs of opposite sides parallel. Both pairs of opposite sides parallel. Both pairs of opposite sides congruent. Both pairs of opposite angles congruent. Diagonals bisect each other. And consecutive angles are supplementary. Consecutive angles are supplementary. So, if any quadrilateral fits all 5 of these characteristics, and only these 5 characteristics, then it is a parallelogram. Then next, we'll look at a rectangle. Now you see we only have 2, we're only going to be putting in 2 characteristics, but everything that goes with a parallelogram also goes for a rectangle. So all of these characteristics drop down as well. So for a rectangle, both pairs of opposite sides are going to be parallel. Both pairs of opposite sides are going to be congruent. Both pairs of opposite angles are congruent. Diagonals will bisect each other, and consecutive angles are going to be supplementary. And in addition to that, with rectangles, we have 4 right angles. We have 4 right angles in all rectangles, and our diagonals are going to be congruent. Our diagonals will be congruent. And remember, diagonal is going across the inside from one angle to the opposite angle. Then rhombuses, their characteristics, they share everything with parallelograms as well, except they're different than rectangles in that they have 4 congruent sides. Rectangles have the 4 congruent angles, the 4 right angles. Rhombuses have the 4 congruent sides. And the diagonals are perpendicular. Diagonals are perpendicular. Remember, in our rectangles, our diagonals were congruent. In a rhombus, the diagonals will not be congruent, but they will be perpendicular. In a rectangle, diagonals are not perpendicular, but they are congruent. And then also, each diagonal bisects a pair of opposite angles. Each diagonal bisects a pair of opposite angles. And then squares. Everything from parallelograms, everything from rectangles, everything from rhombuses. All of the above. Squares have 4 right angles. Their diagonals are going to be congruent. They're going to have 4 congruent sides. Their diagonals are going to be perpendicular. Each diagonal is going to bisect a pair of opposite angles. Both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. Diagonals bisect each other. Consecutive angles are supplementary. So squares encompass all of that. They encompass everything from parallelograms, rhombuses, and rectangles. So let's look at some examples and see if we can figure out how to classify these examples. And we'll do the rest of the family tree in a later lesson. So our first one, we want to classify each quadrilateral and be as specific as possible. So if we look at number 2, these aren't going to necessarily tell us each characteristic straight like just from our markings, but we can still figure out each characteristic that could be there. So looking at number 2, we see that our diagonals, remember our diagonals go across, they're perpendicular. They cross at a right angle. So looking at our family tree, where diagonals are perpendicular is under rhombuses. So we've already eliminated parallelogram and rectangle. Our only options are rhombus or square. And then looking at the rest of it to figure out, now we don't have our angles marked at our vertices at the corners, but we do still have our diagonals. It shows that our diagonals bisect each other, which is a characteristic of our parallelogram. But it shows me that this diagonal, where it bisects, those smaller segments are congruent to each other. But the other diagonal shows that those are congruent to one another, but not congruent with the other segments of the other diagonal. So it tells me that this green diagonal is a different length from the blue diagonal. Okay? So if my diagonals are not congruent, then it can't be a square, because a square pulls down from the rectangle side that diagonals are congruent. So this has to be a rhombus. Rhombus, R-H-O-M-B-U-S, rhombus. Okay, looking at number 3. Now on my screen, this looks like a rectangle. It looks like it's longer than it is wide. But then on my computer screen, it looks nice and even. So You just have to really focus on what information is given to you rather than just what the picture looks like. So looking at this, I can see I've got 4 right angles. So that eliminates parallelogram and rhombus. It leaves me with either rectangle or square. And then the other information it shows is with my diagonals. My diagonals form a right angle, which means that they're perpendicular. So diagonals are perpendicular with rhombuses. But I already determined that because of the 4 right angles, that it can't be a rhombus, that it has to be either rectangle or square. But if diagonals are perpendicular is not something that is characterized by a rectangle, then it has to be a square, because everything from rhombus drops down for square also. So this is a square. We have 4. We're able to determine that from 4 right angles. And the diagonals being perpendicular. We can rule out rectangles because the diagonals are perpendicular. We can rule out rhombus because of the 4 right angles. And that leaves us with square. All right, next up, number 4. We see that our opposite angles are congruent. If we find that in our family tree, both pairs of opposite angles congruent is under parallelogram. Okay, so we don't know if it could be a square, rectangle, or rhombus yet. So far, we just know about parallelogram. But then we have these 2 sides marked as congruent. Now, if those 2 sides are marked as congruent, we can also imagine, if we imagine our diagonals like this, or at least imagine that diagonal, that forms an isosceles triangle on that right side, right? We've got the 2 congruent sides, which would make those 2 angles congruent. So because all of our opposite angles are congruent, or both pairs of opposite angles are congruent, we know it's at least a parallelogram. So that means my opposite sides are also congruent because they're also parallel. So this side is going to be congruent with that side, and the other side is going to be congruent with its opposite side. So I know all 4 sides are congruent. That's a characteristic of a rhombus, 4 congruent sides. So this also has to be a rhombus. So we're able to identify easily the parallelogram characteristic of the opposite side or opposite angles being congruent. But because of the sides that it showed, I can also determine that it is a rhombus because I have 4 congruent sides. So a lot of these you are going to have to think critically and think, all right, what else can I prove from what I know? So you really have to think about some of these things. All right, looking at number 5. We see that all of the opposite sides are parallel. So we at least have a parallelogram. Both pairs of opposite sides parallel. And then we have 2 of our sides. We see that they both have a measure of 8. So if they both have a measure of 8, then I know that side is congruent to that side. And now this is almost just like number 4. We know it's a parallelogram because the opposite sides are parallel. Just like in number 4, we knew it was a parallelogram because both pairs of opposite angles were congruent. And then we had the 2 sides there showing that they're congruent. So I know that the opposite sides have to be congruent. So the opposite side of the one on top, which is down there, has to also be 8. The opposite side of the one on the left, the one on the right, also has to be 8. So all 4 sides are congruent, and we know it's at least a parallelogram, so it has to be a rhombus because 4 sides are congruent. We know it's a parallelogram, so rhombus. And if you want to pause the video, see if you can figure it out on your own on any of these, do that, and then just unpause and see what we come up with. So number 6. Number 6, we have the top and bottom sides are parallel, and they're also congruent. So they're parallel and they're congruent, they're the same length. And this isn't written in your family tree, but we did talk about parallelograms with or a way to prove that it's a parallelogram by an opposite sides, one set of opposite sides being parallel and congruent. So that's what we have here. We have one set of opposite sides, both parallel and congruent. So we know it's a parallelogram. Now we have to look at what we can figure out from our diagonals. So our diagonals show that these 2 segments of the diagonals are congruent. So what that tells me, if I know it's a parallelogram, and parallelograms, what it tells me about diagonals is that they bisect each other, and if they're bisected, I know that this is also congruent to the one at the top left, because it's the same diagonal. It was bisected, it was split in half. And that tells me that the one at the top right is also congruent to the one on the bottom left. And they all end up being the same. So our diagonals are all congruent. So we know it's a parallelogram, and our diagonals are congruent. Diagonals being congruent is a classification for a rectangle. So this is a rectangle. This is as specific as we can be. It may look like a square, and it may actually even be a square. If I got out a ruler and measured those sides and the angles, I might find that it is a square. But the most specific we can be from the information given is that it's a rectangle. Because remember, a square is a rectangle. A square is also a rhombus. A square is also a parallelogram. A square is all of those things. And you may hear this phrase, or if you haven't heard it, you'll hear it now. A square is always a rectangle, but a rectangle is not always a square. So you just have to follow the characteristics that we know. We start a parallelogram. All of these things can be parallelograms, but they may not be those other things. Parallelograms can be, or just not always those other things. But a square is all of those: rectangle, rhombus, and parallelogram. So looking at the next one, number 7. What is the most specific classification we can give it? So we look at our diagonals. Our diagonals, all of the bisected segments of them are congruent. So we know that the diagonals are congruent. So then we can look at, it has to be either a rectangle or a square. It's at least a rectangle. But then we look at our side lengths. This one is 12. This one's 16. So we know it's not a square because 4 sides are not the same. Our sides are not all the same. So this has to be a rectangle also. Then number 8, we can see all 4 sides are congruent. So it's either a rhombus or a square. And then if we look at our diagonals, we know that our diagonals are going to bisect each other. So that also has to be congruent. That also has to be congruent. So our diagonals are congruent. So diagonals are congruent, and we have 4 congruent sides. That pulls from both rectangle and rhombus, so it has to be a square. Got the 4 congruent sides and our diagonals congruent. All right, that's it on the notes. Make sure you do the homework.